Okay. All right, so now we'll look at section 10-3, and this is part 2 of displaying data. But in this section, we're going to be constructing and interpreting line graphs. Also, we're going to use scatter plots to determine the trend and association between the two variables. And then we'll also determine the association between two variables. I think I kind of repeated myself in these objectives here. But in this section, all we'll explore is other graphical displays, mainly the line graph, the scatter plots, and trend lines. All right, so let's look at line graphs here. A line graph typically shows trends in a variable over time. Okay? A line graph typically shows trends in a variable over time. All right, so time is usually marked on a horizontal axis, as you can see. And time can be things like age in years, or time could be in minutes or seconds or whatever. But, you know, that would be the horizontal axis. The variable being considered would be marked on the vertical axis. Okay, so we consider this here, the age is in years, that's on the horizontal axis, and then over 10 years, the weight in pounds is on the vertical axis. And if you have consecutive data points, they're going to be connected by line segments, as you can see. Consecutive data points are going to be connected by using what they call line segments. And that usually shows a trend. And in this case, here you can see as Susan's weight over 10 years, from age 0 up to age 10, you can see that she has been gaining weight. Okay. So what you're seeing here is an example of a depiction of continuous data. Now, all other data that we've examined before have been what we call discrete data. Okay. And by the way, discrete data is something, it's going to be something like data that's usually, that can be counted, that you can count. Okay, so if I had to count the number of students in a particular class, that would be something called discrete data. Or the number of students that participated in the survey, that would be discrete data. Okay, but here I'm examining something over a period of time that's continuous. All right, now on the next page are just some abuses of statistics. Now, one of the abuses could be something like this, where the graph does not convey the same message, like the one on the left, the number of graduates of a community college. Okay. Here, you can see that it is increasing from 2004 up to 2007. And then in 2008, there was a sharp drop in the number of students that graduate out of that community college. But if you were to change your horizontal, your vertical axis like this, then what's going to happen here is this, they're going to look at this and say there's not much of a decrease in the number of graduates at that community college. So you want to keep your horizontal axis as uniform as possible, so that way it can truly depict the type of trends that a particular community college in this case would have. Okay. That's how statistics can be, that's one way statistics can be abused. So let's look at an example of a line graph and how we can answer questions from that line graph. Here we got a graph showing how the value of a car depreciates each year. This graph helps to find the trade-in value of a car for each of the 5 years. The percents are given in the graph, and they're based on the selling price of the new car. Let's say I want to answer parts A through D below. So in part A, what is the approximate trade-in value of a $130,000 car after 1 year? Not $13,000. Okay. The car had a value of $13,000, and then let's say we want to trade that in after 1 year. So here, that's the point for 1 year. What would be the percentage here? And this is between 80 and 60. Let me see, 65, 70, 75, 80. That looks like 75%. Oh, I'm sorry, 70%. You're right, 70%. And you're probably going to have to figure out, what those marks mean. So we're looking at 70% of the average, the trade-in value will be the percentage of the selling price, which is 70%. So we need to do 70% of $13,000. 70% of $13,000. And in this case, this will be 0.70, and the word of means to multiply $13,000. $9,100. So after 1 year, the trade-in value of that vehicle will be $9,100. Okay. And in part B, how much has a $20,000 car depreciated after 5 years? So here's 5 years right here. Here's that dot at 5 years. So let's find out. Yeah, 30%. So after 5 years, the car has depreciated by 30%. So we're looking at 30% of, and this is in this case a $20,000 vehicle. So we have to do 0.30 times $20,000. All right, $6,000. Now that only represents the value of that, the trade-in value of that vehicle. We want to know how much it depreciated by. So we need to subtract 6,000 from 20,000. How much? 14,000. So that car is depreciated by $14,000. Right, questions on part B. Okay, now part C. What is the approximate trade-in value of a $10,000 car after 2 years? Well, there's 2 years. So here's the point where that's at. And let's find out what the percentage there would be. Be 55%. So the trade-in value would be 55% of now 55% of the $10,000 car. $55% of 10,000 would be 5,500. Questions on part C. And part D. Danny wants to trade in her car before it loses half its value. When should she do this? Yeah, because 50% is right here between 40 and 60. So somewhere between the second and the third year, she needs to consider trading in that vehicle. Questions on example 1. All right, now example 2, this one is just a plain multiple choice. Where Coach Garcia kept track of the jumping records for the basketball team for a 10-year period. And let's say we want to draw a line graph of that data. So notice the year is at the top row, and then the number, the record in inches is right underneath it. And we want to select the graph that corresponds to those data points, or best fit those data points. Well, we want to choose which one of these for this data. So which one do you think would best fit this data set, A, B, or C? Is B. Because I noticed at B for 2005 and 2006, they're both at 70. So here's flat at 70 and then drops to 64, goes a little bit back up to 69, stays at 69, goes up to 74, goes a little bit up to 76, and then falls to 73. Okay. So it'll be graph B for this one. All right, questions on this example 2, dealing with line graphs and how to answer questions regarding those line graphs. All right, next we'll look at a scatter plot. Now, this is more likely used in statistics, by the way. I teach a course in statistics where we talk about scatter plots. Now, a scatter plot is where we can find a relationship between variables. Of course, a broken line graph would not help. So usually, scatter plot, hence its name, means that you have a plot of points that are scattered. And usually, the scatter plot shows a relationship between the number of hours, in this case, studied, and quiz scores. So the highest score is a 10 and the lowest is a 1. So pretty much we can find a relationship between hours studied and a student's test scores. So pretty much, as you can see, the more hours a student studies, the higher the test scores will be. So there's a relationship between the number of hours studied and quiz scores. Now, we're going to include something called the trend line. Okay, so as you can see, a trend line is going to be the line that closely fits the data and can be used to describe it. And we can use a trend line to make predictions. Okay. So here, that trend line that you see in red is usually graphed along the points that are close to it. And we usually call that the line of best fit in statistics, by the way. Okay. Now, there are three different types of associations that we have: a positive, a negative, and also no association. Here's what a positive association looks like. If that trend line slopes upward from left to right, if it goes up in this direction from left to right, that means we have a positive association. So we can say that an increase in the value of the variable on the horizontal axis would predict an increase in the value of the variable on the vertical axis. So as x increases, the y increases. Now for a negative association, that means that notice that your points will be falling from left to right. It slopes downward. That means as your x value increases, your y value on the vertical axis will decrease. And then finally, you have no association, meaning that the points are all over the place. That means that we can't make a prediction of one variable based on the value of the other. So usually when your points are scattered all over the place, that means there is no association. So let's look at these two examples that we have here. All right, and it says that what type of association exists for the data, and is there an identifiable trend? It's so sketchy, but we're not going to do the sketch. We want to look at these and determine whether we have a positive or negative or no association. What does part A look like? A negative association. As you can see, these points are falling if you go from left to right. So in this case here, there is a negative association between the two. Now, what about part B? No association. You got points all over the place. That means we cannot make a prediction about those data points between one variable and the other. Now let's look at this example here. Let's say we are given a trend line and it had the equation. In this case, y equal 2.4x minus 0.65. What y value would you expect to obtain when x has the following values? So in parts A, B, C, and D, you're given those values, and we want to, let's say, determine the value we would expect to get. All right, so in this case here, our equation there is y is equal to 2.4x minus 0.65. So now we're given that A for part A is going to be 1. So that means that x is going to be equal to 1. So we want to find out that y value that we would expect to obtain. So this means that y is equal to, now let the x out here. So this would be 2.4x. And then x, we replace that with 1 minus 0.65. So y in this case would be 2.4 minus 0.65, which is how much? 1.75. So for x being equal to 1, we would expect to get a y value of 1.75. All right, questions on part A. All right, B, you have 0. That means X is going to be equal to 0. So we just substitute 0 in for X in our equation of that trend line or line of best fit. So this is 0 minus 0.65. How much? Negative 0.65. So at 0, we would expect to get a Y value of negative 0.65. Okay. Questions on part B. All right, part C. With 13, that means X is equal to 13. So that means Y is equal to 2.4 times X, which is 13, minus 0.65. Okay, 30.55. So my Y value that I would expect to get would be 30.55. And part D would be 20.4. So in this case here, this will be Y is equal to 2.4 multiplied by 20.4 minus 0.65. Okay, 48.31. So at 20.4, I would expect to get a Y value based on that trend equation of 20.4. I mean, 48.31. All right, any questions about example 4? Okay. Now on to homework, well, example 5. If a trend line has equation Y equal 13X plus 0.3, what type of association would you expect the data to have? It's either going to be positive, negative, or no association. It'll be positive. Here's why. This equation, Y equal 13X plus 0.3, that's in slope-intercept form. And of course, if you remember slope-intercept form, that's Y equal mx plus b, where the coefficient of your X term is going to be the slope. And the slope here is 13, and it is positive. So that means our the type of association we would have for this data set, well, if there was a data set, it would be positive association. All right, questions on example 5. Okay, on the next page, deals with multiple line graphs. Multiple line graphs. These may be used together to demonstrate different sets of data when comparisons may be made. Okay. And we have what they call broken line graphs. Okay. And earlier we did look at some examples of graphs, well, line graphs that were broken line graphs. So here, this graph shows the crowdedness of housing between 1940 and 2000, with one line showing crowded with more than one person per room and the other showing severely crowded with more than 1.5 persons per room. Okay, and the legend, as you can see, is given. The red represents crowded, the blue severely crowded. And this is what the graph looks like between 1940 up to 2000. Okay. So pretty much you can just see what that looks like, and pretty much you can answer questions that are regarding broken line graphs. Like in this case right here, let's look at homework example number 6. It says here, the graph to the right shows the number of snow shovels sold in winter months at a store in 2010 and 2011. Now the one in red is the broken line graph for the number of snow shovels sold in 2010. The one in blue represents the number of snow shovels sold in 2011. So we're going to use that to answer parts A, B, and C. And that's this. During which month did the store sell the most snow shovels in 2010? What was that again? It was in January, yeah. Because here, this was sold in 2010, as you can see, and then you got another peak in 2010 as well. And it's in January. Now, part B, during which month did the store sell the fewest snow shovels in 2010? What was that again? Wait, yeah, I don't know.
2010.
Gotta be, well, okay. The fewest in 2010, it would be November. Here it is. The one in red represents 2010. And I guess the most was in January. Yeah. Now, based on the snow shovel sales, which year, either 2010 or 2011, seems to have had the most snow in the store's locale? It will have to be 2011. And what do you think would be the reason for that? Yeah, they sold more shovels in February, but January and February. Yeah. In January, February 2011, they sold more snow shovels than they did in January and February 2010. All right, questions on example 6. Okay, so on the last page, just talks about choosing the display, which is not easy because there's no one direct graph or display that would best be appropriate for the information that you have or the data that you have. So there's always more than one. Now for a pictograph, that would be used to show data with pictures and symbols if that's your choosing. A dot plot would be used more often to show frequencies. Now a stem and leaf plot, we use that to show each value in a data set and to group values into intervals. And then you have a bar graph. Now, usually a bar graph is when you're trying to compare numbers of data items in categories. Like freshman, sophomore, junior, and senior, you want to use a bar graph for that because you want to group those in categories. Now, a histogram, we compare numbers of data items typically grouped in numerical intervals. Now here the order matters and the data in the data depicted. So you just cannot say on that horizontal axis, let's say start with 70 to 79 and then go from 40 to 49 and so on. You can't do that. It has to be in order from 40 to 49, 50 to 59, 60 to 69, and so on. Okay, so you have to put them in order. Circle graph is used to show division of a whole into parts. But again, probably that wouldn't be recommended according to a graphic designer because of how much ink that it would take to even do a histogram. Also the percentage bar that's used to used to divide a whole into parts. Line graph shows the data values changing over time, and that's usually for continuous data. And the scatter plot that's used to show relationship between two variables. Okay. All right, so that's all of section 10.3 right there. Okay. And that will do it for today.
All on spring break is the homework. So
Yes, yes.
Quiz and writing assignments.
I might put a writing assignment number 2 up there, but I don't think it's going to be due on Monday.